So once again, you're welcome to Maths for You. We're going to look at the topic called SURD. And after the end of this topic, you're supposed to be able to understand what a SURD is, know how to simplify SURDs, add and subtract SURDs, multiply SURDs, and then finally be able to rationalize SURDs with monomial denominators. Let us look at the definition of a SURD. A surd is a square root which cannot be reduced to a whole number, or it is an irrational number that cannot be expressed as a finite decimal or a fraction. Let's take some note here. Now the square root of prime numbers are all surds, and then a rational multiple of a surd is a surd. Let's look at examples of all these theories. So is a square root which cannot be reduced to a whole number. So basically, SURDS is talking about numbers that find themselves under the square root symbol or the radical sign. So if we have, let's say, a set of numbers from 1, 2, 3, 4, 5, 8, 12, 16. Now let's have a look at these numbers. Now these numbers, as you bear with me, are all whole numbers. Let's begin to put them under the radical sign and see the meaning they will make. So if I put the square root of 1 under the square root symbol, this will be equal to 1. And what is the reason? Why is the square root of 1 equals to 1? Now what this means is that the number under this square root, what other number can I square in order for me to get the number here? Now if you look at the numbers or all the whole numbers, it is only one that when you square, you'll be able to get 1. Therefore the square root of 1 is equal to 1. What about the square root of 4? Now this also means that we are looking for any whole number that when we square, we should be able to get 4. And you'll bear with me that that particular number is going to be 2, because 2 raised to the power 2 will be equal to 4. Therefore, the square root of 4 is 2. Is that okay? So if there is any number that finds itself under the square root sign and cannot be reduced to a whole number like 1 or 2, then that number becomes a surd once it is under the square root sign. Therefore, let's see this. The square root of 3. Now, what whole number can we square in order to get 3? That is difficult to do, right? Therefore, the square root of 3 will remain as the square root of 3, or is going to give us an infinite decimal. Therefore, the second example comes in that it is an irrational number that cannot be expressed as a finite decimal or a fraction. Is that okay? Good. So that is enough for now. Now let's talk about the notes we have over there. Let's talk about the notes. Now the note says the square root of prime numbers are all surds. So what are prime numbers? What are prime numbers? These are numbers that has only two factors, 1 and the number itself. So example 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. Is 9 a prime number? The answer is no, because 9 has more than two factors, that is 1, 3, and 9 itself. Therefore, the only factors in there are not 1 and 9. So 9 is not a prime number. The next is 11 and many more. So if any of these numbers is found under the square root sign, then we are talking about, or we are looking at, a surd. Secondly, a rational multiple of a surd is a surd. Yes. So talking about rational has to do with rational numbers. Is that okay? So if we have rational numbers, all these numbers we are seeing here are all rational numbers, even though they are prime numbers. Is that okay? But we know rational numbers are all the numbers you can see, which are easy to simplify. Is that okay? So even fractions, some fractions fall within rational number. Alright, so let's make it easy and quick. So if any of these numbers is to multiply another surd, let's say the square root of 5 multiplies 3, this will be equal to 3 the square root of 5. That is all that means. Is that okay? Alright. Let's look at how to simplify surds. To simplify a surd, look for a perfect square factor within the surd and then simplify them. Example, the square root of 18 can be simplified as, we look for a perfect square of 8 within 18. Is that okay? So we want to look at numbers that when we multiply, we will be able to get 18. Now if you pick 1 and multiply with 18, we'll get 18. 2 and 9 will give us 18. 3 and 6. So let's list the numbers. We have 1 and 18 itself. We also have 2 and 9. We have 3 and 6. And that is all. So these are the factors of 18. Now out of these factors, which of them is a perfect square? So it is 9 that is a perfect square. Therefore, the pair of numbers that can give us 18 that contains a perfect square is going to be 2. It's going to be 2 and 9. So therefore, we pick these 2 and 9 and then we multiply them. So we are going to have 2 times 9. Now, if you have watched the video on the properties of how to multiply SURDS, you realize that this can also be written as the square root of 2 times the square root of 9, whereby the square root of 2 will be the square root of 2, and the square root of 9 will become 3. Therefore, a rational multiple of a surd is a surd, so the answer becomes 3 root 2. Let's look at another example. We have the square root of 24. The two numbers to which one is a perfect square to give us 24 is 6 and 4. Therefore, the square root of 24 can be expanded as the square root of 6 times 4, which will be equal to, which will be equal to the square root of 6 times the square root of 4, and that will be equal to the square root of 6 will be square root of 6, the square root of 4 will give us 2. Therefore, our final answer becomes 2 square root of 6. Let's look at the third example. The square root of 98. Okay, the square root of 98. Now, the two numbers to which one is a perfect square are 49 and 2. These numbers, when multiplied, will give us 98. So it will be equal to, now here we apply the splitting, so it becomes the square root of 49 times the square root of 2. This will be equal to the square root of 49 is 7 times the square root of 2, which is going to be equal to 7 square root of 2. So that is it about how to simplify sets. All you have to do is look for two numbers that when you multiply, you will get the number in the same square root sign, and one of those numbers will have to be a perfect square. Once you get that, you simplify.